Okay, so let's continue on talking about solving polynomials. Like I said in the last video, to solve a polynomial, and we're talking about quadratics now, you got to use the zero product property, where you take the two binomials, set them both equal to 0, and solve for your roots. Plural, two roots. Now, just like I said, sometimes your polynomial equation won't be in that format. You got to get it to where you have your two binomials set it equal to 0. So in order to do that, you must factor. To get it ready to solve, the step before that is factoring. So let me give you a definition. What does it mean to factor? All right? So the definition of factoring is writing a polynomial as a product of other polynomials. And I'm going to say other polynomials because you'll find out that when we factor, sometimes you'll get two binomials, and that's coming, I think, in the second half of the unit. Today, you may factor and get a binomial and a monomial, something like that. But either way, you would take that information, set it equal to 0, and then solve to get your two roots. Now, to factor a polynomial, here's what you have to do. To factor a polynomial, you must find the GCF, take it out of the polynomial, and determine what is left. And you're like, what, Mrs. Udoka, what are you drinking? I have no idea what you mean. Don't worry about it. Just write it down, okay? So when we're factoring, in this case, because factoring, is going to be a little different after our mid-unit test, we're going to focus on the GCF, identify what that is, and we're going to take it out of the polynomial. And then when you take it out, you've got to figure out, well, what's going to be left? After I pull out this GCF, something's going to be left. Some other terms are going to be left there. That's the pieces of information that we're going to have to set equal to 0 and to solve for our roots. All right? Now, I said GCF about 2 or 3 times. Let's talk about the GCF. Now, you may not have heard of this term since you were in the 4th or 5th grade. GCF means greatest common factor. All right, greatest common factor. Greatest means this is the largest number that 2 or 3, because we may have 3 terms, have in common. The greatest, highest number that they have in common. You used to do GCFs all the time, so we're going to kind of break it down a little bit because we got to remember how to find a GCF. So let's practice a little bit. You have there on your practice. I'm going to write all this down. 12 and 22. I want to find the greatest number that goes into both of them. Then I want to do the same for 24 and 48. What's the greatest number that multiplies into both 24 and 48? And how many do you have? 3, 4? All right, let's do, can you still see me? Yeah. Let's do 17 and 51. And then one more. I want to find the GCF of 20, 28, and 40. So I'm giving you 3 numbers to think about. All right? Now, so I'm taking you back. You're stepping back in time to elementary school. Okay? If I ask you the GCF between 12 and 22, you need to think of the number, the highest number that goes into both. All right? So some of you all, you may want to try to do this in your head, but I wouldn't advise it. But I would just, when I was in elementary school, can you see this? All right, here's 12, here's 22. What are all the factors of 12? Well, 1 goes into 12, and so does 2, and so does 3, and so does 4. 5 doesn't. 6 does. And I think that's it. You go from 6 straight to 12. These are all my factors of 12. Can y'all see that? Then I do the same thing for 22. What numbers multiply into 22? 1 does, 2 does, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then you dump to 22. Now, what's the largest number that both of them have in common? The 2. So the greatest common factor is 2. All right? Hopefully that brings that back to memory. So I'm going to stop the video for a moment, give you a chance to do the next 3. I'm gonna go over them, but give you a chance to try to do them on your own. I'm going to set up a table for probably number 4, but if you can try to figure out